Hi, this is Mrs. Vrobel. This is part 2 of chemical reactions. So in the last video we talked about how to write chemical equations and how to balance them. And now we want to identify the types of chemical reactions. Because you want to be able to describe what's going on with those chemical reactions. So we have a number of classifications. The first type is composition or synthesis. So when you're baking chocolate chip cookies, you're taking several ingredients, combining them together into one cookie. Very similar with composition or synthesis. Notice that you have two or more reactants and together they form one product. So whenever you see one product listed on the left, listed on the right, I keep saying that wrong, you're going to identify it as a composition or synthesis reaction. So all of these reactions have only one product. The next type is what we call decomposition. This is actually the inverse of composition reactions. So instead of having multiple reactants, we only have one reactant, and that one reactant will be on the left. Notice that there's two or more products. So with decomposition reaction, we're looking at essentially taking one reactant and making it into two or more products. Now, single replacement reactions are a little more challenging to see, but the way I look at it is I look to find a reactant that's by itself and a product that's by itself. And I'll show you an example of that. So look here. If we have the letter A, so the letter A is on its own in the reactant side. The letter B is by itself on the product side. So when we're looking at a single replacement reactant, notice that zinc is by itself. And then here for the product, we have hydrogen gas, it's by itself. Now you might say, well, there's an H2 there. Yeah, there is, but notice that there's only the element hydrogen. There's nothing else combined with it. The same goes here. Here we have fluorine. So fluorine is by itself, even though it's got a subscript of 2, and chlorine is by itself. So what happened is the chlorine atom got replaced with fluorine, and that's why you see elements by themselves. That's only for single replacement reactions. Okay, double replacement is a little more complicated. So if you want to imagine you have two sets of partners, and they decide that they don't like to dance with their partner, so they switch with another person. Same thing is happening here. So notice that we don't have elements by themselves. That's usually a good indicator that you're talking about double plate replacement. So A is tired of dancing with B, so he decides to join D instead. And the same thing is happening with partner C and D. So C switches D with B. Now, lots of times with double replacement reactions, we get production of a solid in the product. So when you look at double replacement reactions, most of the time you're going to have some kind of precipitate or solid. So don't be surprised if you see that with a double replacement reaction. Here's another example of a solid that is being produced by a double replacement reaction. Okay, the next type is combustion, and that's probably the more favorite ones out of a lot of reactions here. The way you know you have a combustion reaction, I typically look for the presence of O2. If they say that this reaction occurs in air, that's a good indicator that we're talking about a combustion reaction. Remember when I struck the match, okay, that was a combustion reaction. So whenever you see the presence of oxygen, and another good indicator of a combustion reaction is in the products you have carbon dioxide and water. lots of times when you are burning hydrocarbons. So when you turn on your stove, you are burning hydrocarbons. You're undergoing combustion. When you turn the key in your car, you're essentially taking those hydrocarbons and turning them into carbon dioxide and water. You could have other reactions that don't necessarily produce carbon dioxide and water. Notice that H2S, when it burns in oxygen, it actually produces SO2. So this is a little bit different than carbon dioxide. It's not a hydrocarbon, so it's not going to produce carbon dioxide. Now this one is a little trickier because if you had to guess, this is a combustion reaction, but what other kind of reaction would you call this? You could call this a synthesis reaction because you're taking two reactants and making that into a product. So this could be considered a synthesis combustion reaction. So you could have reactions that qualify for more than one classification. Okay, now types of products that drive double replacement. I mentioned about precipitate. So here we have a series of chemicals that when they combine, they essentially form a solid. It's usually a good indicator that we're talking about a double replacement reaction. Notice that you're dealing with a lot of ionic compounds, and these ionic compounds, when they combine, they essentially create a solid product. So in addition to formation of a solid, you could get formation of a gas. Notice that it's a little bit similar to a combustion reaction. The only difference is we're not reacting in air. We're using sodium carbonate combined with aqueous hydrochloric acid, and that essentially produces carbon dioxide and water. Another type is essentially a acid-base reaction. Now we haven't really talked about acid bases, so I'm not so concerned about that, but you could get production of water in a double displacement reaction.